Hello folks, we come to the part 3 video of this miscellaneous exercise. We'll start with this problem 6, which says that there is a determinant a squared bc ac plus a squared plus ab b squared ac ab b squared plus bc c squared. You've got to show that this is equal to 4 a squared b squared c squared. Now let's see how to show it. If we carefully go through this, we are able to see that in the column 1 a is common, in the column 2b is common, and in the column 3c is common. We could have them common, we could take them out, and then let's see how it works. So let's start. Consider the LHS, and we could say taking a comma b comma c common from c1 c2 c3. What works? A b c has come out common. Here what remains? It's a plus b, b. Here it is c, d, b plus c. Last column c is common, so it is a plus c, a, c. So that's how the things are coming out common. Now it is for us already out of 4 a squared, we always keep an eye on the RHS, and in the RHS it's being told that you require 4 a squared b squared c squared, out of which already ABC we have got. That means if we get 4 ABC more, we are through. So how do we go about it? Either that we use some of the properties over here, or we can go in for an expansion. Both ways it's correct. Let's use some of the properties and let's see how we can simplify this. Probably we would go in for AC is there here. Yeah, we can do maybe C1 becoming C1 minus C2. Let's see what happens. You will have A minus C. This is minus b, so a remains. This is minus b minus c, so minus c remains. C, b, b plus c, a plus c, a, c. We could have these two columns added up, or we could have it subtracted or added up, whatever it is. So let's have C1, C3 getting added with C1. What is the advantage? You will have a minus c here, a here, minus c here. This is C, B, B plus C. When we are adding it, it is plus A minus C, so C will get cancelled, we'll have 2A. Then it is A plus A, it will become 2A. And then here C minus C, so that will be 0. Like that, you can have a 2A common. C3 has got 2A common, so you can have the 2A common. Taking 2A common out of C3. 2A common from C3. So what happens is already there is an ABC out and you are taking this 2A. So what is remaining? You are having A minus C, you are having A, you are having minus C, you are having C, you are having B and B plus C. But in the last column, since we have taken things common out, here we have 1, 1 and 0. So either you, at this step itself, you can expand. Otherwise, see, since you have already got a 0, and since there is this 1 and 1, maybe you can do some mathematical conversion there and make it more simplified. So maybe you can have R2 becoming R2 minus R1. Let's see what happens. 2a squared bc we have already got. So what is happening? R2 we are operating. A minus c, c1 stays as it is. A minus, you are operating this, so minus a plus c, minus c and minus 1. So it is going to be c here, it's going to be b minus c here, it's going to be 0 here. Minus c, b plus c, 0. It's advantageous because you have got 2 zeros. That helps our expansion very much. Either you can go further and use your properties, or you can go in for an expansion. 2 zeros in a matrix is good enough. Determinant is good enough. You can get the values easily. So I don't think a minus c will give you anything, because when you expand the determinant, there is nothing at all. So you are taking the middle value c. Now C also will not give you anything in the expansion, so it's only the last entry that's going to give you an answer in the expansion of the determinant, because we've got zeros on this place. So 1 time, what is it? 1 time C into B plus C minus C into B minus C. Overall C is common, we could take it out. 2A squared B C squared. What is left? B plus C minus B minus C. Open it up. Minus B plus C. B and B can cut. We have once again, it is 1 times c times b plus c, and yeah, it is minus into minus plus by the determinant formula. So this will come as c has gone out, so it is plus b minus c. Like that, we'll have the plus c minus c cut and b remaining. So you have 2a squared bc squared, b plus b is, sorry, c plus, what is cutting cut? Yeah, b plus b is 2b. So your final answer is 4a squared b squared c squared, and that's exactly our RHS. That is what we want, and that's how we prove the result. Hence proved. So that's about the proof about this problem. Now once we are done with that, we are moving to the 7th problem. Now what is given in the 7th problem? They have given us A inverse, A is not there. They have given us B, and B inverse is not there. They have asked us to find AB inverse. As a property, we know that AB inverse is B inverse into A inverse. So if you have to find AB inverse, it is enough if you have B inverse and A inverse. But unfortunately, we have got A inverse, we don't have B inverse, but we have B. Because we have B, we know how to calculate it by the adjoint, so we will calculate what is B inverse. Once we have found the B inverse, we are able to get the AB inverse. This is how our working is going to be. So our task is to find out B inverse. Let's find the B inverse, and we are able to get the AB inverse. Let's start right away. So we are now considering B. Consider B, which is 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, 1. As usual, let's get the minus and then the cofactors from there. B11, B12, B13, B21, B22, B23, B31, B32 and B33. First we will just look out for the minus. Later on we will go in for the cofactors. So B11 is 3 for us. B12 is minus 1 for us. B13 is 2 for us. Then B21 is going to be 2 minus 4, that is minus 2. Then B22 is 1. B23 is minus 2. B31 is plus 6. B32 is minus 2. And B33, it is 3 plus 2, 5. Now we will give it the cofactors. This will change sign. This will change sign. There is a sign change. There is a sign change. So this is our cofactors. What we are going to do is we are going to get the adjoint matrix. But before that, we will also have to get the determinant. Let's see the determinant of B, and the best way to get the determinant maybe by taking the second row or the third row. Both is equally okay. Let's take the third row. In the third row, we have B23. Third row, B31, B31, B32, B32, B33, B33. Let's get the entries here. B31, 0, no need to take. B32 is minus 2. And its corresponding entry here is 2. B33 is 1. And B33 for us is 5. So, minus 4 plus 5 value is 1. So the determinant of B is 1. That solves much of our problem. Now let's get the adjoint of B. Adjoint of B is transpose 3, 1, 2. 2, 1, 2. 6, 2, 5. We'll quickly check whether it is correct or not. 3, 2, 6, 1, 1, 2 and 2, 2, 5. Yeah, that's correct. So that gives you your B inverse. B inverse is adjoint of B by determinant of B, but determinant of B is 1. As a result, it will be only reducing to adjoint. So 3, 2, 6, 1, 1, 2, 2, 2, 5. Now we can find out AB inverse. They have asked us to find AB inverse, and by formula AB inverse is B inverse into A inverse. B inverse we have found out it is 3, 2, 6, 1, 1, 2, 2, 2, 5. And A inverse, it's given to us 3, minus 1, 1, minus 15, 6, minus 5, 5, minus 2, 2. Let's multiply this and get the answer. First entry, 3 3s are 9, 9 minus 30 plus 30. Let's see, 3 3s are 9, minus 30 plus 6 5s are 30. Okay, so that means it is coming to 9. Yeah, so value is 9. Next entry. Minus 3, then plus 12, minus 12, so minus 3. Net effect is minus 3. Then we have last entry 3 minus 10 plus 12. 3 minus 10 plus 12. That means it is minus 10 plus 2, it's plus 2, 3 plus 2, it's 5. So this value is 5. Then we have the second row, 3 minus 15 plus 10. So that means it is minus 5 plus 3, which is minus 2. Later we have the next entry, it is minus 1 plus 6 minus 4. So that means it is minus 5 plus 6, which is plus 1. Okay, next entry, 1 plus, this is 1, minus 5 plus 4. So 5 minus 5 is coming as 0. Next entry, 3 2s are 6, 15 minus 30 and 25. So this is 31 minus 30, net effect it is 1. Minus 2 plus 12, minus 2 plus 12 minus 10. So it's minus 12 plus 12, entry is 0. Then it is 2 minus 10 plus 10. Again, minus 10 plus 10, entry is 2. This is the final answer that we get. We just cross check. 9 minus 3, 5 minus 2, 1, 0, 1, 0, 2. Yes, that is what is the answer for AB inverse. Question asks us how to find AB inverse. For that we have found out B inverse, because we were not given, we were given only B. We found out B inverse. B inverse into A inverse is the formula for AB inverse. That's how you get the final value. That's all about this problem. With the next problem, we are meeting in the next video. Thank you.